Right, let's make a start. A very warm welcome to you. Welcome to Measuring Whole Life Carbon in the Built Environment. My name is James Fiske. I'm the CEO of BCIS, who's obviously responsible for releasing these webinars. I also chair something called the Built Environment Carbon Database, which is something that we'll be hearing about during this series of webinars. Now we've split the webinars into different parts. Today's part is focused on the basics. This is really sort of making sure that we're all talking the same language, using the same kind of terminology, which is something that, if anybody works in the construction industry, is fully aware that we do a fantastic job of using different acronyms and different things and confusing ourselves. So the part one of our webinar series is really focused on the basics, terminology and sort of methodology. Future webinars will be focused on things like data and reporting in a little bit more detail. So this one's sort of a first step into measuring whole life carbon in the built environment. Please feel free to ask any questions that you want during the webinar using that question mark that's been highlighted on screen. My intention is to try and get through as many of those questions as we possibly can in the time permitted, but for those that we don't get round to today, we're going to be answering and continuing the discussion and debate on the BCIS LinkedIn group, which is the web address that you see in front of you. This session is also going to be recorded, so don't worry if you're having any technology problems. There's an awful lot of people, large numbers of people on this call today. Fingers crossed the technology will work and hold up. But don't worry if not, because you'll have the ability to view the recording, which will be sent to you and also posted on bcis.co.uk. And obviously any questions that you've got, and they may be, actually, James, you didn't explain this well enough, or James, I disagree with what you've said there. Let's post those discussions and sort of comments on BCIS LinkedIn. It's important we all get aligned, so let's if you can do that, that will be great. When leaving the session today, you're going to be prompted to give feedback on today's event, and that feedback will help us make sure that we're delivering something which is the highest value to you for future webinars. So again, if I haven't explained things well enough or you disagree, let us know, and we can adjust that in sort of future webinars. Also, if there's any topics that you want covered in future BCIS webinars, then please let us know on that feedback form. Just a brief slide on BCIS. I'm not going to go into detail on this. BCIS has been around for about 60 years, and its job is really taking lots of information and presenting and analysing that data and providing what is incredibly important information for the construction industry. I often describe it by the various stages of a project process, all the way through from an initial appraisal stage, where you're thinking about building something, all the way through to design, which obviously evolves from early design sort of choices that you would make, all the way through to very, very detailed, this particular material giving this level of performance. The next stage is obviously a construct, so that's when you're actually building the thing, and then you have hopefully a very long operational phase where you're running that asset throughout its life. Once it reaches the end of its life, there's obviously an end of life stage, which could be demolition or it could be refurbishment, and sort of many permutations thereof. So within the construction sort of process, there's quite a few decision gates, business cases, and things like payments and variations and claims that need to be done. Well, BCIS has been designed to provide information at these critical stages. So that will include things like cost per meter squared of different sort of building types, durations, how long it takes to build, all the way through to sort of, elemental, different sort of elemental rates for, concrete frame, steel frame, different external wall options, roof types, etc., etc. And unsurprisingly, I hope, during that more detailed design, the rich detailed information is available on BCIS. We'll go all the way down to material quantities and costs for particular activities, productivity rates, so how long it takes to build, for example, something like a meter squared of brick wall, the common example that a quantity surveyor like myself would use. You can find that rich information within BCIS. Even during the operational phase, you'll find lots of life cycle cost related information, the cost of replacements and maintenance and renewals, all the way through to insurance information, which would include things like rebuild costs. If something unfortunately not great were to happen to your asset, how much would it cost you to rebuild? So BCIS provides a lot of information over to the insurance market. And then finally, at the end of that operational phase, the typical costs of demolition and refurbishment again are available through BCIS. So if anyone's interested, bcis.co.uk has a lot more information about what BCIS has, along with insights and for example, webinar recordings are all available on bcis.co.uk. Okay, well, let's get into what we're here to talk about today. Climate change. And unless you've been kind of living under a rock, you know this is the greatest environmental challenge of our time. It's quite scary, some of the statistics that are being sort of bounded out there at the moment. I've just got a few here just to sort of set the scene. I'm not here to enter into a big scientific debate on climate change. I'm literally just going to spell out some of the information that we have, and you can obviously make your own decisions on those. But when we're talking about climate change, that's due to what we classify as human-generated greenhouse gas emissions. That's our first acronym, GHG, the greenhouse gas emissions, and they're commonly referred to as carbon emissions, which, because they're being released into that atmosphere, are highly likely to have severe adverse environmental, social and financial effects around the world if those temperature levels continue to rise. But it's climate change. It's not probably explained by some of the rather strange weather patterns that we've started to see. Lots more rain, all the way through to extreme cold, all the way through to extreme heat. Climate change is a big complex topic. I guess the important thing for us in this particular webinar is to realize that 40% of those global greenhouse gas emissions come from the built environment. Latest projections sort of indicate that if we don't do anything about them, they're going to double by 2050, which is incredibly scary. So we need to be doing something about it, and hopefully that's why you've joined this webinar series today, so that we can start to report and reduce our emissions in the activities that we're doing in the built environment. It's important to understand that what I'm talking about today isn't business reporting. So the UK government has something called the Streamlined Energy and Carbon Reporting, SECR, another acronym for you, a policy which came into force, I think it was around 2019, if memory serves me. This replaced the CRC Energy Efficiency Scheme that some of you may have heard of. Well, this government sort of reporting follows the greenhouse gas reporting protocol, which is used around the world. Unfortunately, for me, my own personal opinion here, it's just focused on large companies reporting their energy use. So it doesn't cover all of the bits that it should, and it certainly doesn't cover all of the companies, but that's my personal opinion, and not reflective of BCIS in general. My normal caveat when I'm presenting. Yeah, when you're looking at greenhouse gas protocol, it's split into scope 1, scope 2, and scope 3. Brief explanation there. There's a lot more information on scope 1, scope 2, and scope 3 across the internet, so I'm not going to cover that in detail. Scope 1 is the emissions that a company is responsible for directly. Scope 2 is when they're importing energy and the emissions associated with the creation of that energy that they're importing. And then scope 3 is generally stuff that happens not within that company, but it may be a supplier of the company that's creating emissions. And also scope 3 relates to the stuff that happens sort of downstream as well as upstream. So it's not necessarily just pulling in that all of the emissions associated with using a supplier. It's what happens to the thing that you've done once it's passed down the supply chain. So when it comes down to whole life carbon in the built environment, we don't break it down into scope 1, 2, and 3, because quite frankly, they're all bad. They're all emissions that are going up into the atmosphere, and it doesn't matter from from a reporting perspective on the built environment whether it comes from a particular company or multiple companies. It's all stuff which is going up into the atmosphere that we need to be reducing. So we don't break down into scope 1, scope 2, and scope 3, as you'll sort of see as we sort of go through today's session. Built environment greenhouse gas emissions are measured and reported as carbon, but it's CO2e, and the E stands for equivalent. There's lots of people that I've spoken to that thought that the E was embodied or embedded. Beg your pardon. CO2e stands for equivalent, and what that actually means is that what we're taking into account is not just the carbon dioxide emissions, it's the other gases and nasties that are produced during the construction phase. They're all translated into a single number using a global warming sort of comparator, sort of an equation that takes those gases and reports it as a single number. So the E stands for equivalent. And when we're looking at built environment carbon emissions, generally we're talking about two different types of carbon that we're trying to measure and report. The first one is embodied carbon. Embodied carbon again has sort of different terminologies, and we're going to come on to this a little bit later, but if you think of embodied carbon as all of the energy which has been used to create something possibly in the past, so think of a construction product. It's all of the energy associated with extracting the raw material, transporting that raw material over to the place where it's manufactured, the manufacturing process itself, and that's commonly referred to as sort of a cradle to gate embodied carbon number. And again, I've got another slide that sort of explains this in a bit more detail. Then you've got the emissions associated with after that component has been created, the transportation of that component over to the site, i.e. where you're building your building or piece of infrastructure. Then you've got the emissions associated with actually putting all of those construction components together. So that could be on-site electric or the use of diesel excavators, whatever whatever is involved in that installation process. There's an emission that's obviously involved in that. And then you've got cradle to cradle sort of embodied carbon, which is all of the ongoing sort of maintenance and end of life type calculations that we'll be talking through. The other one is operational carbon, which is, if you think of it crudely, is the emissions sort of associated with the heating and lighting of the building that you're in. Now, regardless of whether you're talking embodied carbon and operational carbon, don't worry, I am going to come into more detail on what those things are. Both of those are reported in weight, usually in kilograms, but obviously with enough of it, once you're aggregating into a building level, generally reported as tons. I often get asked, as a quantity surveyor, we're quite used to sort of pound notes. We kind of get that. So I thought I'd have a go at sort of defining what a ton of carbon dioxide looks like. Well, there's a nice little image for you, which shows the volume of a ton of carbon dioxide. If we think of that in terms of a typical sort of not a large by any means, but a relatively size sort of office building in a city, we could be talking a considerable volume over the life that building is responsible for. And trying to put that into context, we now emit over 34 billion tons each year. And if we compare that to what happened in 1950, the world emitted 6 billion tons. So it shows the level of increase which is going on at the moment, which again is quite scary. The typical emissions throughout a building's life will obviously change. So the design phase is generally a relatively small amount of emissions associated with it. Manufacturing all of the materials that we were talking about earlier would generally be sort of a much higher proportion. The distribution of those, the transportation of those products over to site, again, would be relatively small, depending on obviously where you get you get those materials from. Again, we'll be covering that in a little bit more detail shortly. The construction element itself, again, would be relatively small. It's the operation that obviously has a big significant impact in terms of the emissions. So the ongoing, heating and lighting and other things associated with the operation of your building will generally be a much larger sort of proportion of the emissions associated with a building or a construction asset. And then finally, the refurbishment, potentially demolition, would be a small proportion. Now, they're sort of rule of thumbs. I think the important thing to realise is that depending on the building type and the usage, those things can vary quite a bit. Now, this was provided by Sturgis Carbon Profiling, used in the RSES professional statement, and this shows three different building types, where you've got an office, you've got a warehouse, and you've got some residential, and you'll see that those proportions are changing quite a lot. If you think of a warehouse, the embodied carbon associated with the warehouse will proportionately be much higher than it would be for something like an office, where obviously the ongoing operation, the heating and the lighting and other bits of an office would be significantly higher than something like a warehouse. So those proportions will change depending on not just the building, but how much it's being used and other things, of course. So these are only really rule of thumb type information, just as a bit of background. So why am I here to talk to you today? Well, if it's not painfully obvious, it's our duty to try and reduce our emissions as much as possible. It's our duty to the planet to make the right decisions now. We can't reverse the decisions that we make, and that's not necessarily just an ecological, environmental type voice. If you build something now, you're stuck with that thing for the next 60 whatever plus years. So picking the right sort of specifications of things now has a direct correlation to the levels of maintenance, the levels of cost associated with maintaining, and obviously the environmental emissions associated with all of that work that you have to do during that operational phase. So picking the right specifications, making the right choices up front is really important, and we need to make sure that we're thinking about those things even at an early stage of construction. There's a number of studies out there that show that our ability to reduce emissions reduces as the project sort of evolves. So at a very, very early stage of the project, you have the greatest potential to reduce the construction emissions associated with what you're building. So the earlier on that you can get involved in thinking about these things, the greater impact that you're likely to have. Okay, so basically speaking, the challenge that we have in the industry at the moment is that if you ask 5 different carbon accountants, if I call carbon accounting as a profession, if you ask 5 different carbon accountants to do an assessment of the same building, you're going to come up with 5 different numbers at the moment, which is a bit of a problem. Now, that's not necessarily that one of those carbon accountants is better than the other. It's the fact that they're all likely to be using slightly different methodologies to what is included and what is excluded in their assessment. They're all likely to be using different data, and by data I mean different numbers for concrete, different numbers for steel, and you put those 2 things together, and unfortunately that means that we don't really have huge amounts of consistency in this area at the moment. So we're trying within these webinar sort of parts to address those. So this webinar will be looking at the methodology, which is determined by the RICS professional statement, which I'll come on to obviously during this particular webinar. The second webinar is going to be focused on the availability of consistent data. So again, that issue that's fueling that inconsistency in reporting at the moment. A lot of that is about data. So our second webinar is going to be focused on data, where you can get hold of it, what you need to be looking out for, those sorts of things. And then the third one is about trying to make this as easy as possible. So as we go through the webinars, some of this is quite complex, and if it's complicated and complex to do and it's taking time to do it, that's not good for anyone. So the third part of our webinar series is about trying to make it as easy as possible, linking to existing information and processes that are going on within the construction industry. So part 3 will be about sort of trying to make it as easy as possible. So methodology, as I've already sort of indicated, we're really driving the methodology off the RICS professional statement, something that came out in November 2017. I was lucky enough to be as part of the working group involved in that, as well as the carbon guidance on materials that came out before it, and this really set the scene. This really tried to make a big difference when it came out in 2017. Now, the professional statement itself is really built upon the foundations of something called EN 15978. I'll try not to quote too many of these numbers during these webinars, but that's obviously the standard that we're using throughout Europe at least. The RICS professional statement has looked at that and tried to fill in some of the gaps, because even EN 15978 is up for a bit of interpretation in places. So the idea behind the professional statement was to use the foundation of the EN 15978 and try and plug in some of the gaps to make sure that if you're an assessor, you know exactly what to include and what to exclude. So the RICS professional statement is available freely on rics.org to members and non-members of RICS. RICS are in the process of updating the professional statement as well. That I think will be available certainly for consultation around sort of March time. That was the latest sort of timeline that I had from RICS on that, and that again is trying to evolve this to make sure that you know we're really trimming down the areas that are up for interpretation, making sure that people know exactly how to measure and what to include. So everything I'm talking about today is really drawing upon that RICS professional statement, and depending on the feedback that you get, we can go into more detail with this. We can get RICS involved in those webinars to explain certain parts if that would help. So the RICS professional statement, and I appreciate if you haven't seen this before, it might look a little bit daunting, but it's quite easy to understand as you sort of go through it. The framework for reporting and measuring whole life carbon assessments is really determined by this diagram. Hopefully you'll be able to see my cursor. So the first block is around product, which we were talking about earlier. So the emissions associated with the raw material, the transportation of that raw material, and the manufacturing of that raw material into a construction product, which is A1 to A3. A then continues into the construction process. So the transportation of that material over to the site, and then the associated emissions by putting all of those components together, i.e. the construction process itself. So that's sort of stage A, which is obviously really important to understand. Stage B is about the operational phase, so the stuff that happens in use. So we've got use, maintenance, repair, replacement, and refurbishment. So all of those activities where you're going through to maintain things, replace things, repair things, any emissions associated with any of the construction components that you have during the life, all need to be measured in sort of stage or module B. The bigger ones, perhaps you could argue, would be the operational energy use. So the heating and the lighting type energy is reported in B6, and operational water use is captured in B7. Sort of section C, module C, call it whatever you want, is about the end of life. So that would be taking into account the deconstruction, demolition activities, the transports, the waste processing associated with those things, and maybe even, you know, where you can't reuse stuff, obviously the disposal associated with it. So sort of section C sort of deals with all of the end of life. And you'll see those terminologies that we were talking about in the earlier slides. So we've got the product emissions, cradle to gate, the product and the construction sort of process, which is the cradle to practical completion. And then you've got the cradle to grave, which is all of the ongoing operational and end of life activities. Now there's another module which we're not going to dwell on too much in today's session, but could be the focus of another one in itself, which is about considering the potential reuse, recovering, and recycling potential of what you're using. So if you think of something like steel, that at the end of 60, 80, 100 years, however long you've been running your building, you could obviously repurpose that steel. There are other materials that you may not be able to repurpose. So module D is very much about the potential of sort of recycling, and that's covered by cradle to grave, including benefits and loads beyond the system boundary. So again, we're not going to dwell into details on this initial webinar. So as well as having those modules, what we try to do in the built environment is to split it down into the elements. Now these elements are the common elements. Anybody who's used BCIS will be familiar with these because these are our form of cost analysis. So elemental down the left, sort of a little bit more detail in terms of what those things sort of include. So we try to report the emissions of A, B, C, and D if it's possible against each of the elements that you see on this particular table. Now the RICS professional statement obviously understands that to do carbon assessment on every single element at every single stage is quite time consuming. A lot of work would need to be done. So it highlights the bits that should really be focused on. So you'll see that some things are not included within that list. So yeah, focusing on the areas that I guess you can make the most amount of impact in terms of measuring and reducing. Reference study period is something which is named within the RICS professional statement. So the reference study period is how long you want to run the study for in terms of the amounts of years for that operational phase. Because if you think that has a big bearing in terms of the number that you're reporting. If you're designing a building to last 15 years, we'll have a very different number to a building that's you're reporting for a much longer period. So the reference study period is something which is highlighted within the RICS professional statement with some defaults. Now the reality is that the reference study period could be driven by the client, who just wants to look at a certain period of time, or it may be driven by other factors. But what the RICS professional statement tries to do is just say, in the absence of that, these are the defaults that you should use. You'll see 60 years is really there for sort of buildings, and 120 years for infrastructure projects are the reference study periods. Now, there's a huge debate going on in the industry at the moment that, again, I'm not going to get into detail about today, which is 60 years long enough? I'm presenting in a building that's 150 years plus old. I'm sure if you look around, you'll be thinking the same things. So is 60 years driving the right behaviours out of us as construction professionals when we're specifying things? So that's something that I'm hoping will be addressed in a bit more detail on the update of the RICS professional statement. Okay, so I just wanted to give a little worked example of a cavity wall, which is the most exciting thing that I could think of as a quantity surveyor. So what we have here is, during the next few slides, you'll see a sort of a highlighted area over the bit of that sort of diagram that we talked through earlier that I'm talking about. So this first sort of section, we're going to go through the product stage, and then we're going to cover the transportation and construction phase. Then we're going to do the in-use stage, and then a bit on the end of life. So the methodology to calculate emissions associated with something like a cavity wall in our crude example here is that, first of all, you need to understand the quantity of the various parts. You then need to understand the emissions factor of the concrete blocks in our particular example that we're using here at the moment. And then you multiply those two things together to give you the embodied carbon of concrete blocks. Now, obviously, with a cavity wall like this, it's not just concrete blocks. So we need to do the same for any insulation that we're putting in our cavity. We need to do the same for the bricks. We need to do the same for the mortar. And we need to do the same for the wall ties. And then all of those things add up together to give you the embodied carbon of a cavity wall. So it looks relatively simple, quite time consuming, but again, a number of sort of processes that quantity surveyors and estimators would probably go through anyway in order to try and ascertain the costs of the various sort of construction components which are being used in the building. The RICS professional statement indicates where the quantities should come from in a prioritized way. The RICS professional statement says that, the quantities, if you think of that as our first column, that hopefully you can see my cursor going around. In an ideal world, you'd use material delivery records, or you'd use the BIM model, or you'd use bills of quantities, or you'd use estimation from consultants' drawings. The issue with obviously all of those is that they may not have the bits that you need. So if you think something like a BIM model may not have split down all of the various components, it might just be almost a line indicating that it's a cavity wall. So there could be quite a bit of work that you need to do to understand the typical quantities of the blocks and the insulation and wall ties and other things like that. Of course, wouldn't be modelled. Materials delivery records should give you all of that information, but of course, materials delivery records may not be available for every single thing that's been transported onto site. So there's a piece of work that you need to do to understand the quantities. Sources like BCIS will give you typical quantities in the absence of having some of that information, or if you need to break down, what would be a line for a wall on a BIM model, you could use the BCIS information to sort of understand the quantities of each of the constituent parts. Now, the emissions factor so say you've worked out the quantities, you now need to understand the emissions factor for each of those parts. So the RICS professional statement talks a lot about EPDs. EPDs are environmental product declarations, which thankfully are becoming more common in the construction industry. Certainly, I think it was about 12 years ago, I published a book for the Institution of Civil Engineering, which pulled together costs and embodied carbon for activities of work. At that stage, there weren't many EPDs that were available, so we had to rely on all sorts of sources. Now, thankfully, that's changing in the industry, and we'll obviously be talking about this in a bit more detail when it comes down to part 2 of our webinar series. But EPDs are becoming more available. We'll talk where you can get those EPDs in our next webinar. But there is a confidence associated with the various pieces of information that you could use. Ideally, you'd be using an EPD that's been verified for the particular material that you want. If that EPD isn't available, of course, you may have to use similar EPDs for similar materials, or generic sort of averages for that particular construction material type. So all of those have sort of different confidences that need to be thought through. The important thing is that whatever you're using, you've got to state it. You've got to indicate, you've got to tell where that emission source has come from. The other thing to note is that often things like EPDs, even though there are mandatory fields for EPDs, sometimes they're not completed, which is really frustrating. And the units of measure could be different. So you may have something, you may have numbers of concrete blocks, for example, but the emissions data that you have is reporting something different in terms of a unit of measure, i.e. pack of 500 blocks or whatever it may be, or a meter squared of blocks. So you've got to keep your eye open if you're using emissions data to make sure that the unit of measure is exactly the same as obviously what you're using in terms of quantity. The RICS professional statement sort of indicates at the various stages of the construction and sort of design process what's the preferred level of information that you go to. So there's a lot more detail in the RICS professional statement about data, but we'll cover that a little bit more in our next webinar. So you pull all of that information together in our example, and that gives us a carbon reported as a carbon dioxide equivalent in kilograms for our meter squared of cavity wall. So generally that's the process that you'll go through in order to get numbers associated with various building components. There are things, obviously this is quite complex and quite time consuming. That's not complex, it's just time consuming and finding the information. So there's sources like BCIS that we'll be covering in our part 3 of this webinar series about how BCIS can actually help and how information is available on some of these things already, so you don't have to go to this level of information and this level of detail when you're trying to ascertain the emissions associated with your construction component. Okay, conscious of time. Moving on to the transportation and the construction element. So the RICS professional statement gives for transport. Firstly, it gives some default sort of distances which it recommends in the absence of having real data that you can sort of use those default distances, and you use those default distances and you multiply them with the carbon conversion factors which are available on through BECD to give you a transportation sort of number. I'm not a great fan of this, to be perfectly honest. This should really only be used in the absence of having actual real information in terms of your transport. There can be a huge impact. I mean, even as these default sort of numbers shows us, if you're bringing stuff halfway around the world, as opposed to it being really close by, there's a big difference in terms of the emissions and effort associated with those that sort of transport. And obviously you should be taking into account the packaging associated with it as well, which isn't necessarily that easy to draw out of these sort of default values. But yeah, there's defaults there in the absence of having more detailed information. The second table is around the construction process itself. So again, this is the the site cabins, the diesel excavators and other bits that you would have on site. Obviously, we should be capturing those, and we should understand those things as part of this whole carbon sort of calculation. RICS has provided a default sort of carbon per 100,000 pounds of project value in the absence of having that more detailed information. Again, I'm of the strong belief that we really should be moving away from the averages, and we should be, as part of the estimating process, we understand what bits need to be on site in order to pull to install things. So we should really be using that sort of level of information, because it could have a significant bearing in terms of the solutions that we're going for. But the absences are there, so the generic numbers are there, so they can obviously be used in the absence of anything more specific. There's also default sort of site waste and disposal scenarios that are provided by the RICS professional statement that we haven't got time to go into today. Moving swiftly on into the in-use stage. So the in-use stage, where we're covering use, maintenance, repair, replacement and refurbishment. So at this stage, you really need to understand the frequencies of things like how long a component lasts. BCIS provides and did through the RICS professional statement did provide some information on sort of default lifespans for particular sort of components of a construction project. BCIS obviously has a range, has more detailed information, but also a range, so that you can consider whether you want to use the default or actually, in the example that you're trying to build up, it's of a higher usage, so therefore that the expected life expectancy will be shorter because it's getting a lot more use than these sort of default values. And that's the kind of thinking that you need to go through for each component that you're using. How frequently do you need to maintain it? What do you need to do to maintain it? What's involved in that maintenance activity? How long before you have to replace it? What's involved in stripping that thing out and putting a new thing in? All of that thinking sort of needs to be done really in order to understand the use stage of the construction components. Yeah, BCIS has got information not just on the life expectancies, but it's also got something called Life Cycle Evaluator, which breaks down the common materials and shows you the maintenance frequencies and what activities need to be done. So that might be a source which will help you if you're having to do this type of thinking. Last but not least, obviously you've got the end of life calculation as well. So the RICS professional statement talks about the end of life stage, but also clearly indicates that this is about any decommissioning activities, stripping out, the disassembly, the deconstruction, demolition, as well as taking all of that stuff off site, processing that stuff, or disposing of it in one way, shape or form. That's all got to be accounted for in module C. Thankfully, the RICS professional statement does give us again some default values in terms of the recovery rates and the disposal levels. So that sort of gives us a bit of a fighting start. Module D, which we're not going to go into today, is the thinking about the future use, the future sort of recycling of recyclability is probably a better word for our components beyond the life of the particular projects that we're looking at. So it's something we certainly should be thinking about. I guess it becomes a little bit more subjective because we don't know quite what will be done in the future, but it's getting us to think the right way in terms of picking the right kind of products and materials sort of going forwards. Okay, so I'm running out of time, which is my apologies. It's a big topic, but the idea of today is really just an intro into the topic, talking about some of the terminologies and some of the things that you need to think about when you're doing a whole life building assessment. Personally, I think we should be doing more to have sessions like this, to make it available to the industry. Lots of people are being asked to do whole life carbon assessments now, and it's everyone needs a bit of help, I think, to make sure that we're all doing things in the best way that we can. So yeah, if you want to hear more, if you want more detail, if you can use those feedback forms that we were talking about earlier, or post things on the LinkedIn group. If you disagreed with anything that I've sort of run through at a very high level today, then please post it and let's have the debate. So we've got a big challenge. This is all about mitigating the impacts of what we do as construction professionals. We've got to do our bit. We all need to be doing something about it. Now, thankfully, the industry is moving on, and it's moving at a pace, and it is evolving. There's lots of stuff going on, including things like the RICS professional statement or the net zero building carbon standard, and many other things that are going on at the moment, which is great. With so many moving parts, we've just got to make sure that we're moving in the same direction, and that's part of our challenge, I guess. So guidance is available on how to measure the impacts of design choices. I've run through at a very high level today a little bit about the RICS professional statement. It's a good document. It's a great document in terms of reading it and sort of understanding the basics. But obviously, if you would like more information, then please let us know, and we can get somebody from RICS to come in and sort of talk through some of those bits, or the author, any of the authors that were involved in the document. So please let us know if you would like to hear more about the methodology part. The data part is our next webinar, which will be, I think, at the end of end of February, so you can sign up for that. If I haven't put you off during this first initial webinar, the data availability is one which is very close to my heart as BCIS and sort of data, but also BECD, which is the Built Environment Carbon Database. So if you'd like to hear more about that, then please register for that webinar. And then just a general plea that from me that we need to be sharing and we need to be learning from each other. So we've got to get over the mindset of, well, I can't possibly share that because that's my intellectual property or something which is of commercial advantage. When we're looking at reducing emissions and impacts of what we do, the best way of doing that is find out how other projects done it, what worked, and perhaps just as importantly, what didn't work. And it's only through that sharing of information that we're truly going to learn and make some improvements. Okay, well that's really all I wanted to cover today. Let's have a quick look at some questions. We haven't got long to answer them, unfortunately. There's some tricky questions in there by the looks of things on sequestration, which is about timber. So let's. I certainly won't have time to answer all of these by the looks of things. But so when we're looking at sequestration is simply the if you think of timber, timber comes from a tree. Sorry, sounds really basic. As the tree is growing, it's absorbing carbon dioxide, which is fantastic. Of course, we should have more trees. We potentially use the timber in a construction project, and then at the end of the life of the timber, you can generally do sort of two things to it. Well, you may be able to reuse it. That aside, you're either going to burn it to create some heat, or it's going to be left to one side and it will rot. The issue, obviously, with timber rotting is that it releases methane, which is even worse for the environment than carbon dioxide. I think scientists are saying around sort of 27, 28 times as bad. So sequestration, this is covered in more detail in the RICS professional statement, is about how you account for that and making sure that if you're using timber from a source which is, when it's removing that tree, it's planting other trees. So there's a lot more detailed sort of guidance on how you deal with that, what numbers you put to timber on the RICS professional statement. Next question we've got is around mechanical and electrical, the old mechanical and electrical conundrum. So if we use our example of the meters squared of brick wall that we had earlier, that's relatively easy because you've got 4 or 5 parts to it. If you're looking at something like a boiler, that boiler has got a lot more parts, lots of different materials, and trying to work out the embodied carbon of something like a boiler in the absence of an EPD being available for that boiler is incredibly time consuming. So when it comes down to M&E, obviously your default should always be look for the EPD and speak to the manufacturer to see if the EPD is available for that particular mechanical and electrical sort of component. If it's not, are there other ones that are available of a similar nature that you may be able to use? There's some really good guidance from CIBSE on TM65 around embodied carbon for mechanical and electrical sort of equipment. So it's probably worth checking out that guidance. But yeah, mechanical and electrical is still a bit of an issue when it comes down to sort of calculating things. It's an important thing for us to consider, obviously from an operational carbon perspective, but also from an embodied carbon perspective as well. So yeah, it's a case of, in the absence of that data being available, make sure that you're speaking to the manufacturer to say, look, we need an EPD for your particular component. And this is something that we need to put into our assessment. And at some point in the future, it may actually prevent those components from being specified, because in the absence of that carbon number being available, that might be a real block to actually the specification of that component going forwards. So yeah, M&E, it's a case of doing what you can, focusing on the big ticket items. If EPDs aren't available, similar EPDs, generic data from the likes of SIBSI, I think is probably the best thing we can do there. The other issue we have with mechanical and electrical is that I think it's more likely to be innovative in terms of the components that come out. And that obviously could prevent a bit of a challenge when it comes down to knowing how long things last. So if a components come out, you've probably got warranties and things from the manufacturer, but we don't know as an industry how long that thing lasts. So it's a case of using what you can, making sure that you've annotated what assumptions that you've made. A few questions around sort of data as well. Well, data we'll be covering in our second webinar at the end of February. So please do register your interest in the second webinar. Right, I'm being told that I've gone over time by my colleagues, which I apologise for. I'm very passionate about the subject. I make no apologies for that, but I am sorry that I've overrun on all of your time today. So all that's left is for me to thank you for joining today. Hopefully it's been of use. If it hasn't, let me know. If it has, great. And if you want more of it, let's do more of it. Whatever helps the industry drive down emissions is incredibly important to me. So please let me know. So thank you very much for joining. Any questions, please use LinkedIn. This recording will be made available afterwards as well if you do want to watch it again. But thank you very much, and I look forward to seeing as many of you as possible at the end of February for our second carbon webinar around data. Thanks everyone. Take care. Bye-bye.